Hello, everyone. Welcome once again. And we have another live session for you. And this time it is Deborah Melkin. And our topic is single statement, many changes, how one statement can modify multiple tables. Deborah, thank you for joining DPS 2020. It's such a pleasure to host you. And the session is live. There are about 90 people in the room. Take it away.
All right. Well, thank you so much, Amit. And also thank you all so much for having me. I'm really excited to be here and present. I hope everyone who's watching is having a great Data Platform Summit so far. I know there's so many great speakers and great sessions, so I'm just really honored to be part of it this year. So for those of you who don't know who I am, my name is Deborah Melkin. I've been a DBA or a database professional for about 20 years. I've mainly worked with SQL Server, but I've done with some of the other platforms, just enough so I can do some damage. I mainly work with transactional systems, but I've done a little bit with data marts and warehouses, just enough so I could do a little bit of damage. I'm a board member of the New England SQL Server User Group. It is the SQL Server User Group for the greater Boston, Massachusetts area. So I'm based in the Boston, Massachusetts area in New England of the United States. I speak at other SQL Saturdays, other user groups, other conferences. So it's really been a joy for me to get out there and being able to talk to people about SQL Server and geek out with everyone. I'm a Indira ACE class of 2020. I won last year's Speaker Idol at Past Summit, and most recently in the last month, I was awarded a Microsoft MVP for the data platform. So I'm still very humbled and honored by that. This is kind of the unimportant stuff. The stuff you should really know about me is I'm the alto section leader of my choir. I used to go to bluegrass jams regularly before the pandemic. Hopefully, I'll be able to join those soon afterwards. As part of that, I've been learning guitar and I have a mandolin that I keep neglecting. And I'm kind of a musical theater geek. So anything musical, I'm there for. So that's really the important stuff. Although that's not quite the reason you're here. You're here to talk about how that one statement can affect many tables, that one data change. So there are a couple ways that happens. First, we work with explicit changes. We're going to talk about how we specifically write SQL that when we do that one update or insert or delete, we affect multiple tables. Then we're going to talk about implicit changes. And those are the things that we build into our database design. So we do those, we still affect multiple tables when we do that one data change, but we don't think about it. And it's much harder to see how we do those, or we tend to forget that we put those in place sometimes. And then the one I think is most interesting is to think about the changes after the changes. So we think of our statement, our transaction's done, and we're done. That's all there is. But it's not quite true. And sometimes those are things we need to think about as well as we plan on thinking about how we use our data and how we modify our data and how it moves throughout our database ecosystem, I like to call it. So I am presenting live, so I'm really excited to be doing that. But it means that your questions, you're going to have to put those in the chat and we're going to bring those over. And I've got a couple spots where I can ask for questions. And we'll also try to get to as many at the end as possible. So please put any questions you have along the way in the chat. And I'm looking forward to answering any questions that I'm able to about this. But one thing I also want to point out is a lot of the things we're going to talk about are things we deal with every day. But I want us to think about what we do every day and think about it from a different perspective and thinking about how these little things affect everything else and affect the big picture. That's one of the things I love to talk about. And so I want you to kind of come along on that journey with me and think about all these little things that we do that we don't think about and really understand the big implications of those. So we're going to start with explicit changes. So these are those changes that we include directly in our statements. One thing I want to bring out is we actually get to use some internals with SQL Server when we work with these changes. And these are these inserted and deleted tables. So these are system tables that exist just for the duration of that data change, whether it's an insert, update, or delete. You may hear me slip and just refer to all of them as updates just because when putting this together, I kept thinking about an update statement, but most of these will apply for inserts and deletes as well. But these two system tables, inserted and deleted, exist just for that duration of the data change. The structure matches the tables that are being updated. You can't make any modifications to these tables. They're stored in memory. But the thing to remember is that these captured the data in two states. The data as it existed before the change started, which is our deleted table, and the way the data will look once the transaction is committed, and that's what's in the inserted. Because again, the data hasn't fully changed. We can roll back a transaction, but we can see what it's going to look like if we were committed at that point in the inserted. Because again, until that update statement or the insert or deleted statement finishes, we don't know what it's going to look like because it's not committed. So how do we use these in our tables? Well, we can take advantage of them in two different ways. And these are those explicit changes that we're going to really focus in on. One option is our output into statement. And this isn't syntax that you use often. I've seen it a couple times in real world experiences, and I'm like, oh, this is a really handy, it's a really handy syntax. It is part of your change statement, it's part of your insert, update, or delete statement. And what it does, it directs output to variables or table variables or even other tables, right? So there are definitely some limitations. You can't insert into a table which is part of a foreign key constraint, or you can't insert into a table that has a trigger on it. If you use replication, there's going to be some limitations. Your target can't be a remote table, a view, or a CTE, common table expression. And when you start thinking about performance, these last 2 points are kind of key. It will always use a serial plan, and your target tables aren't eligible for parallelism. So if that's going to help you make the insert perform faster or the update, you're not going to have that um, be able to get some of those performance gains if it needed to go parallel, because it won't. That part of the query can't go parallel. So things to think about. The syntax itself is pretty straightforward. We have our update statement here. It's just a basic update. And here we see our output into. So it's output, the columns that we're talking about. And notice I'm using those inserted and deleted tables. So I can say, here's what it's going to be, and here's what it was. And I'm inserting into, this particular case, I happen to be using a temp table, but if I had a regular table that fit the criteria, I could insert into another table directly and put those values there. So it's a pretty simple syntax, but it's a pretty effective one. And as I said, it's explicit. It's right here. We're doing two things. We're actually updating and inserting from the single one statement. And that's pretty mind-blowing because it's not something we think about when we first learn how to do our insert, update, and delete statements. Because we always say you can only insert into one table at a time or update one table at a time. Well, that's not quite true with this. So I think that's a cool thing to think about. But it's also remembering you're updating two tables with that one statement. So thinking about that impact as well. So the next thing that we do explicitly are triggers. Our friends, the triggers. Our frenemies, the trigger, because there's always so much wrong with triggers, or they're poorly written and we're constantly trying to troubleshoot them because we're yeah, we don't always write them well. We don't think about the greater impact a lot of times. So going back over the basics, what are triggers? Those are those special store procedures attached to a table or a view that are executed as part of the data change. So it can happen after the change. It can happen instead of the change. But the key thing, and this is why we have so much fun and so many problems trying to troubleshoot triggers, is it's all part of that same transaction of that data change. So that one insert, update, or delete statement, you are executing everything that's in a trigger. And a trigger is just a stored procedure. I'm sure some of us have had those really long running stored procedures, so you could make a trigger do that as well, but it's all part of that same one transaction. So now we're really talking about how that change is really affecting a lot of information on how it holds locks and how it writes to transaction logs, and thinking about all of that impact. So triggers can be assigned to execute for any of the different change options: insert, update, delete. You can have multiple triggers on a table. They can be for, you can have 3 triggers on a table. They can be insert, update, delete. Or you can have 2 updates and 1 delete. Or you could have 3 for inserts. Um, it's hard to think of why you would want to do it, but it is a possibility. But here's where it starts getting tricky when you start having multiple triggers for the same action. Is what if you need triggers to fire in a particular order in order for the data to work properly? You can actually assign triggers to be the first trigger fired or the last trigger fired, but you really don't have any control in between. So if you find yourself in a situation where you need those sort of actions, it may be something to kind of consider. Do I want this as a trigger, or do I need to rethink about how I'm updating my table so I can make all of these cascading actions occur? So let's take a look at the syntax of triggers. This is a basic trigger. This is a after trigger. If you don't know what type of trigger it is, it's going to be an after trigger. It's the default. So essentially what it says is on my table here, my alter ego table, when I do an update, after that update has occurred, I want to do these following actions. So again, we've explicitly said when I do an update, I want to do an insert as well. So multiple tables affected. And all of this is part of the same transaction. So if any part of my trigger fails, my entire update statement fails as well. Now there's the concept of the instead of trigger. So again, it's the same table, but instead of the update, I'm going to do everything in my trigger. Now, if you pay attention, you'll notice there's something missing in this particular example. And that is, I'm never actually updating my alter ego table. So this, whatever statement, update statement I wrote here is never going to happen because it's not inside my trigger. Because instead of the update, these are the actions. And if you didn't know you had an instead of trigger, you're going to find a lot of problems with that. Instead of triggers do have some good use cases. For example, if you have a view, you can't usually update a view unless it's on a single table. Um, but with an instead of trigger on a view, you can actually do that because instead of trying to update this, you can actually figure out the logic of where the data needs to go on the multiple tables so you can get all the logic working properly and keep your data in sync. Um, but again, it's understanding what they're used for and really making sure you're using them efficiently because again, that update statement is going to be extended, that transaction of the update statement is going to continue for as ever long as it takes for all the triggers on the table or tables or view uh, occur because you can update a table that has a trigger to update a table that has a trigger to update a table that has a trigger. So when we start talking about downstreaming, that's really when these small things that seem okay, we really can start seeing how they build out. So those are the two examples, the main examples we can think of when we talk about explicit ways that we can update more than one table with that same statement. The next piece is we're going to talk about are those implicit changes. So these are those changes that are built inside the database schema. So with that, how do we work with this? The first thing is something we're probably all very well familiar with, and they're cascading foreign keys. So we have a child table, which references a parent table. So when something changes on the parent table, cascading foreign keys say what happens to the data on the child table. So we really start thinking about the relationship of data between the two tables with foreign keys. So, and how do we keep them in sync? And so cascading foreign keys, we do that by building it into our schema. So we can set actions that occur when something happens. So we can set the value to null. So when the parent record disappears, the foreign key value is null if you allow nulls. We can set it to a default. We can cascade the action. So if you're updating the parent table, the child table will be updated, or the child foreign key will be updated to the referencing columns value. If you delete, well, you don't delete a single column, you delete the entire row. So if you delete a row, we're deleting the row in the child table too. Otherwise, you have to define the action yourself and handle it manually. Cascading foreign keys are really cool because you can have a full daisy chain of foreign keys, of cascading foreign keys. The thing to remember is you don't have control over when you have a very large chain of cascading foreign keys, you don't have any sort of control over how SQL Server goes about deleting the different tables. So I actually have seen problems where the cascading foreign keys will delete a table before the child table is deleted because it's referencing another chain off of the very top level parent table. It gets very confusing when you think about that too. This always goes back to if you need things done in a specific order, you may not want to rely on cascading foreign keys to do that for you. You may just want to go ahead and have a stored procedure or build it into your process that you're deleting tables in the order that you need them to, so you don't have any parent key violations or foreign key violations. Um, but it is important to think about that it's a nice way that you don't have to think about that referential integrity because you've already dealt with it, and your application, your database can help your application by keeping the data in sync. So you have to know that the foreign key is there. If you know, otherwise you don't know what the action is, but you can see it when you do an execution plan. So for example, I am updating a table, the alter ego gadget, and we can see in our execution plan that we do the update. But because we have a cascading foreign key, we can also see that it's related to our order line item. And so now we have an update because of that. So both tables are updated. We can see it in the execution plan, but it's not something you're going to see in a trace. So this is where understanding how your database schema is built is really important to understand, because we've just done 2 updates with 1 statement. And so again, when you start scaling things out and you have more in that chain, you're going to have more transactions, more tables affected, thinking about how the data works and how long it's going to take that 1 statement to execute, because it does have to do all the checks along the way. The other way that we can build this into our database schemas are temporal tables, or the system versioning tables. And these are really cool, and I think they have some cool applications. I'm actually getting to play with them a little more in the real world now, so it's a lot of fun. But this was introduced in 2016, and I always thought this was a really handy functionality of SQL Server. So essentially, we're creating system versions of the table, and we're only recording what the changes are. So only updates and only deletes. Because when you insert into a table, you haven't changed it, you've just inserted a record. Now we're capturing the changes over time, or SQL Server is capturing the changes over time. So the versioning is managed by the system. You don't have to build anything in for that. Your history table can be created automatically by SQL Server, or you can personally create it or manually create it. It does have a lot of requirements though, so as long as you're scripting it out properly and making sure it fits all the requirements, which is mainly matching what the parent table looks like or the table you're versioning looks like, you're in good shape. In SQL 2017, they started introducing retention periods for that data, because when you're talking about a system table, you know, your history, if you do have a lot of changes, that table is going to grow. And when you think about what it means to insert into an already large table, you can imagine that at some point you're going to have a performance hit. But not just that, but depending on how you query that data, every time you make an update or delete, you're always inserting those records into another table. At some point, you're going to start having performance issues, or you're going to want to start paying attention to this so you don't have those issues. So this is where having that retention period is really important, and thinking about how you want to handle all of that history information is going to come into play. So it shouldn't be it should be just a normal challenge of thinking about how your database design, but it's understanding that under the cover, no one's specifying it, but you still need to manage those changes along the way. There are some limits for temporal tables because everything has its limitations. History table must exist in the same database. It doesn't have to be in the same schema, but it has to be in the same database. You can't manually modify system date columns on the table being versioned because we're trying to keep everything in sync. And you can't directly modify data of the history table because, again, we're trying to keep everything in sync and really make sure that we have the history accurate. Um, and surprise, surprise, there are some restrictions with replication because replication always has a little bit of restrictions when it comes to these sort of things. Um, so how do temporal tables work? Again, you don't directly modify a table to say insert into this table and insert into my history table. SQL Server will do that for you. One thing I wanted to point out before I share you it in the execution plan is, and this is why temporal tables are cool, and the fact that this stuff is built in. You can query your table to return data as it existed in a point of time. And again, this is a cool advantage of temporal tables and why they're worth looking into. So you can query data to say, I want to see what the data looked like at a certain point in time. You can say, I want to see between this time period. I want to see everything. And, different ways of slicing that data and viewing all the history data without actually having to call that history table. You're referencing the main system version table by itself, and then SQL Server will have the logic to go to the other table for you. Again, that's that side effect of understanding that every change you make is creating insert and records in another table. Again, not a problem necessarily, but something you want to be aware of. And if you didn't know that these tables were system versioned or temporal tables, as you're trying to troubleshoot, it may be why it's a little harder to figure out what's going on. Because as I said, we're not writing it explicitly to say that we're updating a second table, but you can see it in the execution plan. So for example, I'm changing my alter ego table. I'm doing a quick update. And now we can see I have an insert into a history table. So I've system versioned my tables, and now I can see all of those changes. Again, one statement, multiple changes. So those are the things we commonly think about because as we're troubleshooting performance, those are the pretty obvious ones. Why is my insert taking so long? Why is my update taking so long? This should have updated, but I'm not seeing a change. But I think it gets really fascinated once we start thinking about that downstream effect. What happens after the transaction? Because we tend to think of these one statement. Oh, I did my one statement. It's done. It's finished. I'm complete. There's nothing else, right? Well, that's not always the case because there are changes that happen because of that change. So why am I bringing this up? Because it has to do with, we have several functionalities in SQL Server that use the log reader. So what does that mean? Every change you make gets logged to a transaction log, right? So what we do is we have several pieces of functionality that read from the logs, figure out what changes have occurred, and has to apply those changes elsewhere. So if you make massive numbers of transactions on one database, if you have something that needs to read those transactions and do something with it, well, now there's still an effect on tables afterwards. And those changes are still occurring. They may be asynchronous, they're not happening at the same time, they're not happening as part of the transaction, but they're happening because of the transaction. And now we have to follow through with those. And those also have effects. So if something's not right after the transaction, you may have to trace it back to the original one and think about all the implications with that. So what are those areas that we're coming up to that occur for those transaction after the transactions? The first one I would bring up is replication. So we have data changes that are stored in a publication database, and we send them to one or more subscription databases. So we have a distribution database, which has the metadata and history for all the different types of replications. And if you're using transactional replication, we have to keep track of those transactions as well. Things to think about. You can have the same table that's part of multiple subscriptions. So when you change one table and it's part of multiple subscriptions, we've already talking about after that one table change, we still have these multiple tables in other databases, not necessarily other databases, but usually other databases, sometimes on other servers that now have to get those changes. So now we're really talking about expanding out that reach of our one change. And we use SQL Server agent to run the jobs for the various tasks for replication. So now we have MSDB that's affected, making sure the jobs and the history and all of that fun work that we have to do to keep track. There are multiple types of replication. I'm going to focus a little later, we're going to focus a little more on transactional because honestly, when I think about changes after the changes, it really occurred to me that transactional replication is one of the big parts. So this is where it's a one directional transaction replication where we have our main database and all the transactions for the tables that we specify, the articles are getting published. And so that one change goes out to others. And you think about it, a merge replication, which is that bidirectional, would also fall suit under that as well, because it's not just you're changing one database, it's a change in the table for another one that we have to figure out how they go back and forth from the two databases and how do we synchronize those table changes and making sure everything stays in sync. So it's really when we start thinking, for me, thinking about those, that's really where thinking about how you're changing data in one table affects things downstream for replication. Especially when you start thinking about, am I pulling the subscriptions or am I pushing the subscriptions out? And if you have to go over a network, how many changes are you making that have to get pushed over, making sure your network is all set so it can handle the volume of change that is needed to transfer over and the acceptance of like how long you have for lag and updating and keeping things in sync and all those little details that go into it. All comes down to how am I updating that one table originally so then we can read those transactions going further. Another change after the change is change data capture or CDC. So here what we're doing is essentially taking that data, that inserted and deleted data that we were talking about earlier with those explicit changes, and we're essentially writing those to system created tables for future use. So there are some limitations with it. You can't rename the objects that are created for CDC or for schemas. It is all created by SQL Server. They are stored as system tables. I'll show you that a little bit later. There's also a default retention policy. So the data doesn't stick around forever. So if you're using CDC because you need to do something with the change data, you need to see what it looked like before, you need to see it after, and you have to do something with it because at a certain point, that data is going to disappear. And think about the number of times that you've had a client come to you and say, hey, this hasn't been working. Okay, when did it stop working? 4 weeks ago. Well, if your retention policy is 2 weeks, you've just lost a lot of data. And so that can create gaps and that can create problems depending on how you're using it, what sort of and trying to restore data with CDC. There are a couple things that you have to be careful about. Otherwise, that process of restoring the backup could also wipe away all your data as well. So it's a cool function in terms of I need to take this and I need to deal with it, but you do need to deal with the data that you're capturing quickly or have a better retention policy that's going to fit when you can go through and process it. Because again, it's not designed to stay in your system forever. There are a couple other things that do log readers. I just want to kind of mention them. You have database change tracking, which is kind of a lighter weight version of CDC, where essentially CDC says, here's the change, here's what my record looked like before, here's what it looked like afterwards. CDC just says, hey, I changed a record. I changed this record. You don't know what the change is, but you do know that a record changed. Availability groups. So I'm kind of stretching this here because availability groups it replicates the entire database. CDC and replication, you can choose which tables you want. Availability groups is just like, nope, full thing over, copies it here. But I kind of think it's important to understand that change after the change, because we are talking about changes from a transaction log. And availability groups, my understanding is that they use transaction log records from the primary, and those are kind of sent over. It's not quite log shipping, but it is kind of that idea of taking the transactions, confirming, hey, are all my transactions applied before it hardens on the availability group replica. This is where it gets a little more in depth on availability groups than my knowledge of it, but I'm bringing it up because it is how many changes are you making to that primary replica that now need to be copied over to all of the other replicas. So that one change to your database doesn't just affect that one database, it affects everything you need to do to transfer over the networks or to the other servers or however you have things set up so you can get to your other replicas and pass all of those changes over. So because of the lag and depending on how you use availability groups, if you have a read-only availability group because you want to use it for reporting, um, it is important to think about how that one change does affect everything else, which is reading from your transaction logs, because everything that we've been talking about, they're all regular transactions. So those transactions get written to our transaction log, which is also the other thing to think about as we're doing all these multiple changes with that one transaction. How does that affect our SQL Server in general and what we know about how SQL Server works? So I'm going to hop over to demos. Um, just thought this would be as I'm getting a sip of coffee, just thought I'd do a quick check to see if there are any questions that I can answer so far.
Yes, Deborah, there are questions. So shall I call them out?
Yeah, let's take a couple questions.
Okay, perfect. So we have question from Naveen. Maybe you can understand this better. The update statement where it is inserting to the other table will trigger work.
Yes. Um, so I'm assuming this is about that output into statement because we're updating our statement and it's inserting into another table. Yeah, it
Mhm.
is work because SQL Server is updating multiple tables. So again, like you'll see it in the execution plan. So there is a cost to it. Um, this is why I think there are some limitations about what it can do, why you can't do foreign keys, because if you're trying to insert, if the table has foreign keys, SQL Server has to validate the foreign keys. So I think that's one why you don't have the limitation to make it easier. It's not doing those checks. Um, it's probably why it's not just forgetting about parallelism and just a serial plan. So yeah, there is work associated because it is an insert into another table at the same time that you're inserting into the one. So
Sure. Okay, so Naveen has another question. Is there
sure.
any way my trigger will get initiated in case of an in-place update?
Um, it's not you don't initiate triggers. Trigger is just a stored procedure. As long as the trigger, if you disable, you can disable triggers. Sorry, let me start back. By default, triggers are always enabled. Yes, you can disable triggers, but it is a command. So if you had to disable the trigger in a database, you stored it somewhere else, the trigger is already disabled, so you'd have to manually enable it, I believe. Um, so, but that gets into how you create triggers and enabling and disabling triggers.
Okay. So we have another question from Gabriel, and he says, it interest particularly in updating multiple tables with a view if there are performance drawbacks. And another
Sure.
question. Okay, so let's answer the first part of the question. I mean, in a single statement, he has two questions, I guess. But
Okay.
I'll call out the entire thing so that you
Yeah,
get
yeah.
the overall context. Okay, so interest particularly in updating multiple tables with a view if there are performance drawbacks. And another question: the definitive method to update an entire column of a gigantic table.
Ooh. Okay, so to handle the question about a view, if you have instead of trigger for the view, the instead of trigger is a stored procedure. So essentially what it's going to do or what you will have to do is write the trigger in such a way that whatever you have in in those system tables, you're going to want to take that information and be able to parse it essentially. So you can write the insert tables to all the underlying tables of the view properly. And it's understanding that everything that you do within that trigger is within a single transaction. So it's going to depend on how your view is written and what sort of data you need to update the underlying tables with. So again, it's thinking about how you're writing it and making those statements as quick and as efficient as possible, because remember, you're also holding locks on those tables because you're doing an update statement. So it's really thinking about how you're doing it and how everything's structured, and making sure you're being as efficient with your update statements or the inserts or whatever you need to do in that instead of trigger for the view. The second one is about updating large tables. This is where not knowing some of those other, it gets into how your table is structured and how you're doing those updates, but a lot of the same concepts are going to be in place. Like, first, you want to think about how you're updating that table itself. And my personal be, again, you're thinking about how you're dealing with the transactions. If you have a very large table, you may not want to try it. If you have like a 1,000,000 record table, it's not as big as some tables out there, but I'm just going to start with 1,000,000. Trying to update all 1,000,000 records at once may not work depending on what your update statement is. So you may have to do those in chunks. It's also knowing what attachments or what other things are going on with that table. Does it have foreign keys on it? If you're, it is important to understand if you're replicating, or if you have any of those other things associated with it. I think it's good to understand, because again, it may not be something you want to take and count initially. I would say like foreign keys, you definitely want to know if you're dealing with 1,000,000 records and you have foreign keys, and especially if you're updating those foreign key columns as well. It's important to think about how all of that's structured. Very large table, there are a lot of different ways that you can approach that. So it's taking all of that stuff in mind and figuring out the best way that you want to do it. I don't think there's one good standard answer, but it is really something to think about, especially if you have any of these other characteristics or any of these other functionality built into your database, and thinking about how things work. Um,
Okay.
Unfortunately, it's just has to be a very broad answer, but it's definitely something to think about and consider.
All right. Thanks, Deborah, for that answer. We have another question from Chuck. Chuck is asking, possible to use implicit or explicit to insert into several hierarchies tables? One relies on foreign keys of prior. It looks like the question is more about hierarchical structure of the tables, where one relies on the foreign key of the prior.
Yeah, I think it's going to depend on how many structures there are and what you're trying to do. If there's ever a question that if something goes out of order, or you could have a foreign key violation because you're not deleting the child before the parent, I would say be explicit on it. Because I've seen cases where you have these long chains, and SQL Server, if it's going to get into logic issues trying to figure out the way it can cascade through tables, it will tell you you can't create a cascading foreign key. But it will allow you, but because of the way table structures are, it could be set up so a child could be deleted before a parent. If you ever think that that could be an issue, or if you ever need to guarantee that your tables are deleted in a particular order, explicitly write it out. Explicitly delete in those orders. Don't rely on the cascading foreign keys. They can be great because they can help you with that, and that, if something forgets, we can still make sure that the data integrity and those relationship between the tables are intact. But again, if there's any doubt and you needs to be guaranteed, be explicit.
All right. We have another question from Gabriel. The lighter version, best maintainable version to replicate data, is log shipping a good alternative with a certain lag, of course?
Um, that's a good question. I think that's a little beyond the scope for this, because that gets into when you would want to use um, different technologies for like log shipping, or for the high availability and disaster recovery scenarios. I think that's a little bit beyond. I know it's a little bit beyond my personal scope, but it is something that I always like to think about of how it works. So I don't know if I have a good answer for that one. But I would definitely say, regardless of what technology you want to do, you want to think about what those goals are and what those standards are, and then you can kind of work to figure out what's going to best meet your needs.
Yeah, I guess right, Deborah. So, Gabriel, why don't you put this question on Twitter, maybe with the hash SQL help hashtag, and maybe the SQL family can pitch it. With this, Deborah, we are done with the questions for this round. What
All
would you
right,
like to do next?
let's go into some demos. Hopefully, we can see some of the stuff in action a little better.
Absolutely.
So,
All right, friends.
all right,
So, on to the demos with Deborah, but keep your questions coming in the chat window. Over to you.
absolutely, absolutely. Keep those questions coming. These are great questions. So I have a superheroes database. We're going to use superheroes as an example. Um, so first thing we're going to do is we're going to start looking at the output into, and we're going to try taking all these different things we've talked about and kind of build a little bit upon them. So the first thing is I with my database, I have some data. So I I have comic universes, I have alter egos, and people. I don't have any people in my database. So let's add some. Now, my requirement is when I add people, I want them to be added to my alter ego person table. I have a join table to make, by default, everyone is going to be added as an average citizen. So I have my list of people, the people that I want to add right now. And I'm going to use my output into, and I'm going to put everyone into my alter ego person to fit that requirement. And when I run this, I get an error because I can't use output into where a table is on either side of a foreign key. So either it's referenced by another table or it references another table. Um, this is a mapping table. I put foreign keys on them because I like foreign keys. So I can't do it this way. We'll come back to that. So instead, I'm going to add my people, and then I'm going to add them into the alter ego person, specifying that they are average citizens. And so now I can check and I can see that I have people in my table and in my alter ego person. And then if I look at my history, let's just do the history. I can now see my history of the changes I've inserted people, my output into. All right. But as you can see here, I don't like being an average citizen. I want to be Wonder Woman. My demos, I can do that. So let me just make sure I know my person ID and my alter ego. So I can use this and I can now do my update statement. I'll put into in my history table. Whoops, let's try this again. Make sure I've updated things properly. And when I run, we can see that I now have an alter ego of 7 because I was person ID 1. And my history table will look a little different because I ran that update statement twice. So I have 2 different updates, and we can now see that I'm updated properly to Wonder Woman. And now I'm being told I don't belong there because I'm not a superhero. All right, fine. I will delete myself from the alter ego person table, and I will record my output into my history. We can see that alter ego person ID 1 is no longer there, and if I check the history, we can now see I have a delete. So it's a pretty basic use of the output into, a pretty simple example. So let's build on this because this is pretty basic, pretty explicit, insert, update, delete. So now I couldn't quite do what I wanted to with the output into because of foreign key restrictions. This is where we can use triggers to help us. So as I said, my business logic is every time I insert a person, I want to add them to the alter ego person table. So I have a trigger here for insert, and I'm taking that insert statement that I just used with the output into, and I'm just putting it right here in my trigger. So I'm going to create my trigger. And then I'm going to show you a couple things with the execution plan. First, I'm going to show the estimated execution plan, or the execution plan without runtime statistics. Some people are getting very particular about defining what this is. And we can see it's a pretty basic execution plan, and we just see our insert into the person table. Now, when I run this with the actual execution plan, and I look at my execution, first of all, we see a couple of different messages here. So more than one thing happened. So we can now see that we have my insert, and after my insert, we can see the trigger fire. So it's important to note, because sometimes we look at the execution plan and we don't see anything, and it's not till we actually run the query that we see some of those other pieces of information. I know once we start getting to functions, it's the opposite. Certain types of functions, so it's kind of the opposite, but triggers, we see them when they actually run. And if I were to run a trace, I could actually see these statements run, because they are explicit statements. We said, hey, when this runs, here are all the individual statements. And we see them just as we would any internal statements for stored procedures, because that is just what a trigger is. It is actually just a stored procedure. So now we can kind of confirm I am here, I am back in the person table, and I have an alter ego of average citizen. So now let's talk about deleting a person. I need to remove them from this table. So I'm going to create a simple trigger here for delete. And again, it's that delete statement we saw earlier with the output into. Created my trigger, and now I'm going to delete. And I can't, because my delete statement conflicts with a foreign key. Because remember, I created this as an after trigger. So I delete first, and then I'm trying to delete it from my child. Well, we want to reverse that. I need to delete from the child, so then I can delete from the parent. So this means we need to change that delete trigger. So it's instead of actually running my delete statement, I'm running my delete that I had before. So I can delete from the child table, the alter ego person. And now I can do my delete. If I didn't put this in here, I would still exist in that table, because I never actually ran my delete statement. So it's really important that if you're doing an instead of trigger, if you still need that update or insert or delete to occur, you need to add it in the trigger as well. Otherwise, that statement doesn't run. You're still holding the locks, and it still looks like it runs for all intents and purposes, but it's never actually fired. So I'm running my trigger, and now sad to do this, but I'm deleting myself from the person table. And then when we look at the execution plan, we can see it looks like the delete statement ran, but here's what it actually ran. It ran my delete, and then it ran the actual delete from the trigger. And so now if I select from person, I'm not there. And then we could tell from the others that it is still the case. But if we go down here, we can look at the history table, and we can see all those insert and deletes from the trigger that fired, because I had the output into statement. So that's pretty much the idea of thinking about the way triggers work. And these are things that are fairly common. And as you start working with SQL Server, these are things that, again, output into may not be used as frequently, but triggers are fairly common, and it's thinking about how they're using. And again, like you would write any stored procedure, you want to make sure triggers are as efficient as possible. So now let's start getting into some of the implicit stuff. So we'll start with cascading foreign keys. So let's move to my superheroes database. So I created a trigger because I couldn't do certain things without it, like that delete. I couldn't delete the person and have it automatically delete my alter ego person table, because while I had a foreign key, there was no action to find. So let's start playing with that concept a little more. So first I'm going to get rid of that delete trigger. And now we're going to start setting it up. So this is what it would look like with cascading foreign keys. So first I am going to put myself back in the game. So I am now existing. I am now person 9. So now I'm going to delete me. But first I'm going to make sure I'm showing the execution plan. All right, so we get my the foreign key violation. So now we're going to set that cascading action. I like dropping the constraints just to make sure they're dropped. And I always forget to turn off the execution plan when I do these. And what I'm going to do now is I'm going to say, add my cascading foreign key. So when I delete, I'm going to say delete the child record as well. So now when I delete me, we can see I'm deleted and I'm no longer in the alter ego person. And it worked fine. There were no errors. But again, I just deleted from the person and now I'm deleted in the child record as well. So what else can we do? And this was kind of fun because we're going to play with setting defaults because that's not something I tend to do often, um, but it's a cool functionality. So, null means we don't know what the value is. The parent's gone, we don't know what it is. Defaults are cool because we kind of sit there and say, we set a standard for our records. Where do we start with in terms of how the data moves? So here, when we talk about our alter egos, if you don't have an alter ego, we know what the default is. It's an average citizen. So we can sit there and say, if you delete an alter ego, we can just make someone an average citizen. So let's play with that. I'm going to change my foreign key on the alter ego person, going to my alter ego, and I'm going to set it to a default. And I get an error because I haven't set the default yet. So that's something that's good to know. You have to have the default on the column. So I'm going to set it to 1 because I know that 1 is the alter ego ID of an average citizen. So now I can go back and add my foreign key and set it as a default. So let's look for a couple things. So I want to look, and Storm is alter ego 4, and Aurora Monroe is going to be Storm, and she is person ID 7. So making sure I have those correct. Okay, so first I'm going to do update the alter ego, and I'm going to select, I have Storm set up in my database. So now I'm going to delete alter ego, and now I can look, and I can see that the person is set back to an average citizen. So it's fairly simple, it works well. But what happens, that default, it's on a foreign key. What happens if I don't set it to default that doesn't exist in my foreign key table? Well, let's see what happens. So I'm going to go ahead and I'm going to drop my constraints, and we're going to set these up separately. So I'm going to set a default to 0. We know 0 doesn't exist. And I'm going to set up my foreign key, and that worked. So when it creates a foreign key, I'm actually having it check and making sure that the data exists. So if I had data that didn't match, I should get an error. Everything works. So now let's reset our alter ego. We have alter ego 8. Just confirming, person ID is 7. We're going to run our update. And now I'm going to delete that alter ego. So now we have an error because we're setting it to a value of 0. So the default worked, but my foreign key failed because 0 doesn't exist, which is really interesting. And one of those fun things to learn about defaults is that there's no validation of the value that you set as a default until you actually try to insert it into a column. So if you had a varchar default for an integer field, you could create the default constraint. It would just fail every time you had to insert that value into the default. So now I can double check my data is correct, because that change didn't occur because I couldn't, the foreign key failed, so therefore my transaction rolled back and no change was made. So now I'm going to reset everything so we can move on because I think we need this correct later. So now we're going to work a little bit with temporal tables. And like I said, I think temporal tables are cool, but there is a little setup for them. So essentially, if you need to track all changes, insert, updates, and deletes, temporal tables are not for you. You don't want system version. If all you need to do is keep track of updates and deletes, this may be an option. So let's take a quick look at what I have for tables in my database. We have an alter ego person table. And if we look at the columns, I just have 3 columns here. And if we look at the history table I've been using, we notice that there are more than 3 columns. So one thing with system versioning tables is the tables have to match exactly in terms of the number of columns that you have. The columns have to be correct. The way indexing and clustered indexing work are different, but this is really the key thing I want to point out here. So in order to do temporal tables, I do need to modify my alter ego person. I need to define a start time and an end time. They are both date time too, and they are going to be stored as UTC. We're going to store UTC values in these two columns. The other thing that's important is generated always as row start, generated always as row end. So when's our start time, when's our end time. I like this keyword, it's hidden, which means when you do a select star, you don't see these columns. So if you're have an existing application and you want to make the table system versioned, you can hide these columns and the application won't break if it's just saying, hey, pull back everything, because it doesn't know these two columns exist depending on how it's figuring out what columns are on the table. The other important thing is these columns are not null, which makes sense. We're versioning the tables. We're based on times. Notice the defaults. I'm altering a table to add these, so you have to have defaults for not null columns because we need data. I'm setting this default to 1900, January 1st. You could set this to the current system UTC time, and that would also work. This one is pretty standard. The end time is December 31st, 99. So we always have an end time, and that end time is always way off in the future. So we're creating a range from the time it's inserted to some time way, way, way off in the future. The other thing that we need to tell SQL Server is what is our system time. So we're saying, because we can name these two columns whatever we'd like, we need to tell SQL Server what those two values are. So we've created our range. So I'm going to run these. We can drop the constraints. We can leave those there. For some reason, I like to get rid of them afterwards. You don't have to. And so now when I select from my person, it's those three columns that we see before, but I can now, when I specify system start time and end time, I see my column, so I can see my data. So now we want to turn system versioning on. And it's a pretty simple syntax. Alter table, set system version on. This one I decided to set data consistency as well to make sure everything's consistent. And now if I were to refresh my alter ego person table, we notice the icon in Management Studio has changed. And let me do it this way because we're missing something. Where is my table? We're now seeing that it's system versioned. And now we can see that there is another table. So my history table isn't, well, it's a table. It's not viewed with the other tables. It is viewed connected to the table that we want. And if you didn't specify a name, this is what it looks like. And to be honest, it doesn't make sense to me. Like if I were to look at my tables and this doesn't mean anything. So I want to give it a meaningful name. So let me fix that. So now that it's system version, if I want to make changes, I need to turn system versioning off. And most times when you make changes to your tables, you need to turn system versioning off. There's a lot of restrictions and things that you need to be careful of when you're working with temporal tables for that. So now I'm setting it system versioning on, and I'm naming my history table. So I want alter ego person temporal history. So I'm going to go back here. I'm going to refresh. And my system version table's here, and now I have my history table, and it's marked as such. And I can go in here and I can see the same things that I do for for my system version table. Notice something. This is the original table that was created. It does not get dropped. So if you're creating history and then you no longer need that history table, you can, when you turn system versioning off, that table still remains. You still have access to the data. It's still there. So you can still do something with it. So something to kind of think about. So now let's start making changes. So I'm going to change my alter ego trigger that I had before, and I'm going to simplify it. So I'm just inserting into my alter ego person table because now I'm creating a history automatically. So I don't need that output into because I'm going to take care of it. First, I'm going to keep track of this. Notice the date is UTC. So it's one of those things that when you need to deal with time, you need to understand that you're dealing with the UTC date time in these columns. So I'm going to add myself back in. And if I look at my history table, I'm not there. We saw that 2 records were affected because I inserted myself into person, the trigger fired, inserting me into the alter ego person table. But because system versioning is only about updates and deletes, I would not exist, that record would not exist in my history table just yet. So I now have the other women in my person table, and they need to be assigned their alter egos. So first we're going to go here. And I'm just going to do these individually so we can get a little bit of time separation. You know, just to make sure. And when I double check, I can see everyone and I can see who they are as an alter ego. And I always come back here. Yeah, no, my demos, I want to be Wonder Woman, you know, so let's fix this. So I can do something very quickly. Well, if I'm going to be Wonder Woman, I think Diana Prince should be average citizen. And what's the time? Let's get a starting time for this too. All right. Wait, I have to switch back. Fine. I'll run both of these at once. And you know what? Let's do this a couple times. So I'm going to run this 20 times. And so we can see some of the changes. I'm going to grab this date time as well. So let's do this. All right, so let's see how that works. So now we can see how things currently sit. And I'm back to being an average citizen. But you know, I was Wonder Woman at one point. So let's take a look. So let's see what it was at around this time. Nope, that one wasn't good. Let's see. No, this can be the problem because I'm doing everything very quickly. Oh, here we go. Nope, that wasn't it either. The problem with UTC datetimes is remembering how you got all the changes. But we can find the right, if I grab the right time, we could figure out when I actually was Wonder Woman. Let's try one more. Let's change this to 700. So my system time's failing me right now, but we can go through different times and we can say, you know, the time that we started earlier, that first time we grabbed, and we can look at changes through a particular time. So now we can start seeing some of those changes that I wasn't able to grab the right time for earlier. So we can see all of these different changes, and we can see when that record was valid for. So it started here, it was changed here. And so we can see those different timelines, and we can see what all of the data look like. So depending on what you're trying to capture, being able to view that glimpse of time is pretty cool. And you've got some really cool things that you can do with that. And if you ever have any doubt, you can just look at the changes by querying that history table directly. And we can do things with that later. I'll show you in just a second. But the other thing is we can actually create views on temporal tables. And I can create a view to show alter egos. And I can show things based on a particular time. So we can see at this time, hey, look, this is a good time because I was Wonder Woman then. But if we looked now, we would see that it's different. So being able to capture data and show it at that date, at that point in time, SQL Server is doing that logic for us. But there is kind of something that we want to be careful of. And that could be that there's some differences that depending on how quick you make changes. Looking at these, you have the temporal history directly versus system time all, which is show all the changes. And these numbers are exactly even. But remember, I've added a couple extra records here. So my alter ego person includes inserts, maybe things that I didn't change. And when you look at the data, you can sometimes see that if you had things which are a little too close together, they may not show in the other, because what SQL Server will do is if it finds a case where the start time and end time are the same for the same record, it'll collapse them together. I think it's a hard thing to capture. I do have other examples where I did do this when I first started playing with temporal tables. I did a blog post and I was able to catch some of those scenarios. So SQL Server will collapse them so it only appears one record. So depending on how you make changes and how quick those changes are, you may have different pieces of information. So this one, everything worked where I don't have that showing, but it is something to kind of pay attention to. But again, you have to have just everything lined up so in order to capture it. So the next thing is talking about transaction logs and those changes after the changes, because it is important to remember that everything affects the transaction logs. So if I go to my superhero database, I can actually read my transaction logs and I can actually find all of the changes made to my alter ego person. So when you think about how SQL Server uses these transaction logs to say, hey, what changes? I need these changes to go somewhere else. Well, fun fact, I actually have replication set up on this database for a couple of these tables. I just created a little filter here, so you can just see that one database. But if I do this, you can now see I have a replicated database. And I don't want to show you too much, but I just kind of want to get you the idea of what it means for all of these changes. Because the other thing that I did is, while I initialized my replication, I didn't start sending all the transaction logs over. And so when you start doing that, you can start seeing, if I started my log reader, so I'm going to start the agent, and in just a second, you'll start seeing that all these different transactions are going to start going through. I have 121 transactions with all these commands. So when you start thinking about how these things go over, not only that, but my set up transactional replication to use stored procedures. And so when I look at the database and I look at the stored procedures, I see all my replication stored procs here. I can modify these and I can have these store procs do whatever I need them to do. Not only that, I could put triggers on the tables that I'm replicating to. So when the store procedure fires, it goes to updates a table which has a trigger on it, which goes downstream. These aren't things that you normally think of, but when you're trying to troubleshoot performance and thinking of how that one change expands, that's it. So, but I did want to spend a little time and talk a little bit about CDC as well. Because again, this also uses transaction logs to take those changes and store them elsewhere. As I was saying, this is all based SQL Server functionality. So you have to enable it. There's a store procedure and the now CDC is enabled. And now I'm going to enable it for my alter ego person table. And when that starts, we're going to look at our system tables. Whoops, wrong button. Let's refresh. And now I can look, and I don't see anything here that I didn't have before. But when I look at CDC in the system tables, all these CDC schemas, these are created by SQL Server to capture that information. So when I start making changes, let's make just a couple changes here. Every table that we do for CDC has a specific table name created for it. So here it's alter ego person CT, so change tracking. And now I can see the changes. I had 2 updates, and now we can see those 2 update statements, 3 and 4, 3 and 4. So one of these was the change before, and one of these is the change after. And it's interesting that I always find interesting is that it's connected to the LSN. So now we were kind of connecting it to that transaction. So let's see what other data we can do. So I have a gadget order form. And so now I can see that my table is created for CDC. And I just want to confirm a couple things. So I'm still Wonder Woman. Yes, I'm person ID 10, and I've got a couple objects. So I need to order them if I'm going to be a proper superhero. So I'm going to just place orders for everything. But you know what? I'm missing some stuff along the way. So I should make a couple changes. I'm going to change that. I already figured out what the changes should be. Numbers ordered, price. Oh, I forgot shipping and tax. So let's do those. And so now I can see my orders. Oh, wait, at this is a little too much. I'm not going to buy the jet. I'll leave that to someone else to buy for me. So now I can look at my change tracking, and I can see all the different changes that have occurred. Now, when you disable CDC, I disabled it for my table, and now when I go to see, it doesn't exist. So as long as CDC is enabled for the object, it's there. As soon as you disable it, the data's gone. So depending on how you're using it and when you want to use it, it's really making sure that you're taking care of your data first. So we have all of that information. And then if you want to get rid of CDC altogether, you can disable it that way. So I know I'm getting close to time. Are there any questions?
No, not at this time, Deborah.
Okay. Well, hopefully it kind of gave you a good idea of how all of these different things work together and how you can kind of build upon each of these ways that we're updating more than one table at the same time. And really thinking, again, it all comes down to thinking about what your data is, how you update it, and how it moves throughout your system. And that's going to be with pretty much everything that we do with our databases. It all comes down to thinking about how we're using it and what our goals are, and being able to define those and making sure that we're working within those. Because it does become an issue once you start trying to troubleshoot things. So, to kind of review, here are the things that I want to take away. One, you can't see all data modifications by traces. Like I said, foreign key, cascading foreign keys and temporal tables, you don't see those in your extended events or your traces. You see them in the execution plans, and they still happen because you can see the data, but you're not always going to see them. So that's one thing when you think about implicit changes that you want to keep in mind. Not all data modifications occur in the same databases. In fact, if we think about triggers, you can write a trigger to affect a different data, to write data in a different database if you wanted to. So but it's also thinking about, we're talking about changes after the change. A lot of those are in different databases. So it's not just that one database or that one table that's affected. There's a downstream effect to some of our data changes. It's also the amount of data that changes isn't just about that table. I'm affecting 1 million records, but it's how we're affecting the transaction logs, and especially when we get to the changes after the changes, and thinking about what this means for not just transaction logs. I should really modify that, because it's really not, it's the length of your transaction too, because all of this different work that we're adding on extends that transaction of that one statement, because it's not just that one table, it's all the tables when we talk about the immediate transaction. But then we have things that read from the transaction log. So we have to take that transaction and do something with it. And this is the key. It all comes down to how are we troubleshooting the various areas. So it's not necessarily that initial update, but changes occur because of it. And that's why I like thinking about the changes after the changes, because if you do a lot of changes in your database, that's great. But if you have to replicate it, if you need to do change data tracking, um, we still need to read those transactions, and we still need to take everything that we did and do something with it later. And that amount of data can cause problems. It can cause, depending on your acceptance criteria for how long the lag between replication and how long all that data transfers over. It matters how much data you're updating at once and thinking about that initial update statement. I have a bunch of additional resources if you're interested in later, a couple about the output into Eric Darling and I believe it's Paul White have some really cool information about those as well. I have temporal tables, I have change data capture. I included some stuff for database change tracking because I did a little bit of research in case you're interested in that. And I'm going to make my slide decks available later. I have a blog, and from there you can get to my GitHub and I will have these available for you along with the demos, so you can play with those as well if you want to see how those work. If there are any other questions, feel free to let me know. You have my email. I'm on Twitter. This is my blog, debthedba, wordpress.com. And so any questions you have, let me know. Again, it's a lot of these things, if you've been working with databases for a while, you know them, but it's thinking about them in a different format. And again, thanks to Data Platform Summit and all the organizers for having me today. I hope you found this interesting and something to think about as you go back and work with your databases. Well, thank you so much for having me, and thank you all so much for coming.
So, friends, great. And thank you so much for joining this session. And Deborah, thank you so much for coming over and spending your time with Data Platform Summit and sharing your knowledge and expertise with all of us.